Hey, I'm Max and welcome to my idle game tutorial. In this tutorial, at the end we should have this result right here, which includes a updating graph that updates every 10 seconds with the new dollars that you have, different coins that you can buy and sell that changes price randomly, and that gives you an interest based on how many you own. So for example, this one I have 22 now, and every 10 seconds it gives me interest based on that and shows in my wallet. Now let's say over here we want to do dollars times equal 1.1. So it works if we do dot multiply 1.1f, but we want to use the operator because that looks a lot better. So how do we get this operator to work? Well, it's simple. We do pretty much the same thing we did. So public static BigNumber operator times, and we do BigNumber n float m, and here we just have to create our BigNumber result equals to new BigNumber n. Then we do n.multiply by m, and we return our result. That's simple. I'll do the same thing for division, so I'll do divide here, and here I'll do divide by m and return the result. And whoops, I actually made a little mistake here. It's not n.multiply but result.multiply and divide. So now let's see if it works with the operator. And there you go, it's working. It's going up way too fast, and there you go, it went out of the array. If you wanted to make sure that if the number goes too high it doesn't cause an error, you could do something like if index is greater than symbols.length -1 to make sure it's still in there. So if it's greater than that, you can just do return error and it will show that instead. So here we go, we're going up, and now it's going to say error, and there we go, no more error. The only operators we might still need is the greater than or lower than. So to do them, it's very similar to the other ones. I'll just create a public static bool operator greater than, and then I'll do a BigNumber n and BigNumber m. Just like the other ones, I'll create a BigNumber result equals to new BigNumber and copy the n. Then I'll calculate the difference between m.index and n.index, or you can do result.index, it's the same thing. And then all we need to do is subtract them. So I'll just take the same thing that I did here without the while at the end, copy and paste that. So the result is going to be the difference between them on the same power. And then to check if n is greater than m, we just have to check if the subtraction is greater than 0. So if it's a positive, then that means n is greater than m. If you remove m from n and it's still positive, that means it's bigger. So we'll do return result.number greater than 0. Now we can do the same thing for the less than. So we'll just do here less than, and at the end we do less than 0. And we can actually copy and paste both of them and add an equal for the greater or equal than and less or equal than. So now we have greater than, less than, greater or equal to, and less or equal to. Let's test it out here. I'll create two big numbers and compare them. So here I created number 1 and 1000, and I'll check each operation on each one. And thankfully we tested them, because as you can see for the 1k and 100 it works fine, but the 100 thinks it's greater than 1000. So we know this doesn't work fine if the second one is bigger, so it's if the difference is positive. And that's because with the subtraction we did the biggest number minus the smaller number, and that saves us some power. But if we invert the numbers here in the greater than or less than, it inverts the result. So here we'll instead do n minus m and times 1000 to make sure that it's in the right order, and we also want to remove the index thing. So I'll copy and paste that in all of my greater than and less than. And now as you can see, 100 is not more than 1000, 100 is less than 1000, 1000 is greater than 100, yes, 1000 is less than 100, false. Now one last function that I use often when I use this type of number is the sort of power, but kind of not real power. So it's actually just multiplying by a power. So I'll do public void power, and I'll do float power number and power. Then I just do number times equal mathf.pow power number power, and whoops, I forgot to put a float here, and power. And then I just put the same thing as in the addition for the index. So now if I try doing something like power 1.1, 1.1, it should go up pretty slowly. So it goes up pretty slowly at first, and then it goes way faster. I can even use something like 1.1 and then 0.1, to create a very slow start, and then it goes even faster. So you can see it barely goes up 1,000 and then it goes up like 1,000,000 every frame, and it keeps going faster and faster. So that can be useful to create a big increments between the levels of each thing that you buy, because you don't want, for example, in your idle game the first level to be $1 and the second level to be $2 and the third level to be $3. You want the numbers to go up very fast because you don't want the player to be able to save to buy something that he shouldn't buy yet. So I think that's going to be it for part 2 of the series. The BigNumber was a very big part of the project and I'm glad that it's working fine. You can keep going to the next episode if they're out when you're watching this. You can also go check out my other Unity tutorials if you want, and subscribe if you like my channel.